So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 189 and in this video we want to talk about a new keyword, which is the keyword operator. And for this purpose I have already prepared here a little bit code. You can see I have created here a very simple class with just one variable in it, which is public and called special number, and I have just one normal constructor, not a default constructor. We can see this, that I have here a parameter without a default value. And then I have an initializer here, which is just initializing this member variable to this parameter here. And yeah, that's it. And here the body I have put here at the end. And the reason for that is that just to show you that sometimes in coding, they change the style instead of putting all in new lines, which we are used, for example, like this one. Most time you will see that programmers, if they have nothing in the body, they are just putting it at the end of this block here. So they don't want to waste the space and make it in one line, just for style purposes. So, and then I hope this kind of stuff you notice and know by now. And then you can see here is one more thing. It's a normal function with no return type and two parameters, which are int. So back to our CPP website, where we can see this operator overloading and how they describe it. And let's read here the first sentence. It says here, operator overloading customizes the C++ operators for operands of user-defined types. We will try to understand this in a moment with an example here, but before that, let me read here the syntax as well, because we want to use the syntax when I make this example. And the syntax says here, overloaded operators are functions, and that's very nice. So overloaded operator functions with special function names. And this sentence is very nice because now it's very easy to make an overloaded operator, because we need just a function like this one, for example, and we have just to change the function name, and voila, we have overloaded operator. All right, but very important note here, when you read operator overloading, just think about a function with a special use case. And here we have syntax, and the only syntax which we are interested in is the first one. All the other ones we will skip. The reason for that is they are connecting or associating other things with operator. So let me show you this one fast. For example, the second syntax here, it says here operator type. And when we go here down to this explanation, it says user defined conversion function. When I click on it, then you can see it is again a big block which we have to cover. But important is here, we have here not covered many things which we need to understand this conversion. Conversion means we have to cover first this keyword static cast or cast in general, and then we can talk about this. And with the other example, it's similar. You can see the number 3 is using the keyword new here, which we have not covered now. Delayed is connected to this new here. And yeah, to make it short, we are just concentrating in the first syntax. And the first syntax, when you watch here a little bit, it's the basic syntax. If you understand this, it's very easy to understand all the other, because like I said, all these other examples what we have here will be something like use cases in different places. Let me show you this one more time here. When we scroll down, you can see we have here many examples, but all these examples which you see here really use cases with different combinations. For example, we have here this operator equal, but what they are telling you here later in this example is more a copy assignment, a move assignment. And this copy assignment, move assignment is a topic for itself, which comes in classes, because every class had something like a copy assignment operator, and that's the reason why I want not talk about this all special cases with operators. Instead, we will cover the special cases when we come to this places where the operator is used in the other cases. So that makes our life very easy, because we have just to understand this one example here, this basic overloaded operator, and all other things will be easy then, because the same principle are used there in all other places, more or less. Okay, with that said, with that said, we can almost dive into an example, but one more thing. So we have here the syntax. The first syntax is just operator and this op. Let's watch this op fast. Op means here operator, and it's one of the following operators. And you can see we covered most of them, not all of them, but most of them you will realize. And for this example, which I want to use, we use the first one, which is just a plus, and we will change the meaning of the plus in our C++. What this means, I will show you an example, but before that, there is one more thing here to notice. These are not all C++ operators. This is just a selection which are allowed to be overloaded in C++. That's very important as well, because there are some restrictions. When we go here a little bit down, there is a restriction section, and then you can read that some operators are not allowed, and there are some more restrictions. You can see we are not allowed to create any new operators. With combining to create a new operator works also not. And then there is a restriction about some operators, how they are used, or they have some purposes which not count. Let's see, for example, we have here this operator, this pointer operator, for example, and here is a restriction for this pointer operator which you have to consider when you are using it. And here is another operator with another restriction, and so on. Important is this line here 3 as well, because this restriction here, precedence, counts even we use an operator, or even we create a new operator. And this one I will show you also when I make an example. That's very important here too, but better to, let's make first an example and then we will see. And while we are here, perhaps one more thing before we go to the example which I am going to make. Here we have this overload operators, and you can see this operators, this plus and so on. These operators can have a position. What means a position? When we look here, this expression, a position means here, for example, this at here is a placeholder for operators. So think about it. In my case, let's take this plus here. Here, the plus is in position before this A, and A is here, let's say, an operand. So before A, and depends on the position, an operator will be handled in a certain way, and there are different positions here. You can see the operator is here in the front, and then we have only one operand. Let me make here an example. What is an equivalent example? This is, have they one? They have one, but this is a bad example. Let's make an easy example to understand, which is probably this one here. You know this operand plus plus, right? This one is also an operand, and I can increment, for example, let's create first a int number, which is 0. And I can now increment this number with this operand here, plus plus. We learned this already. Number, and you can see this operand now is in front. The position is in front, and this A is called, the operator is in front, and the operand is on the right side of the operator. So this positioning is also very important later, because depends on what kind of overloading you do, you have to consider this as well. And in my example, I want to make here, for example, this with two operands where the operator is in middle. With other words, we already know, for example, not this one, int result equal 5 plus 5, or 7. So you can see in this example here, we have again an operator. This one is the plus, but we have here on the left side operator is called also the left side operand. Here on the right side, the right side operand, because it's on the right side of this operator, and here it's on the left side of the operator and right side operator. All right. So this position is important. There are different kind of use cases, and we will talk about this again in my example, which I make to make it a little bit more clear. But important is also these two columns here. And when we watch this one, the one column says as member function, for example, a member function in a class, and we know this access specifier dot here. So that is a class member function, for example. And here as a non-member function, and a non-member function is like a function which is not belonging to a class. We know two kinds, more or less, or more. But important is here, there are certain operators, for example, this equal operator, which must be in a member class. You can't create it outside of a class. That's also very, let's say that's also a kind of restriction which you have keep in mind, and yeah, to take in account. But we will watch this, or you can watch this later after I make a very simple example to understand this operator. So with that said, let's make an example, right? We have now here my class, my function, and we are back to this sentence here, which says overload operators are functions with special function names, which means to make an overloaded operator, first of all, I need just create a normal function like this. It's the easy way. Okay, let's do this. Let's copy this, and I have now another normal function, but I want to make this function an overloaded operator function. What I have to do is just change the function name to this special function name, and the special function name which I want to use here is the first syntax, and it means I have to use a keyword operator, and then I have to choose one of these allowed operators. In my case, I will choose this plus. So I combine this operator plus, and let's do this. Let's write it here. I delete this function name, and right now this operator, this is the keyword operator, and now I have to choose, like I said, you have to check first which operator are allowed, which operator you want to overload, and so on. And let's make the plus, and that is actually our function. So an overloaded operator is a function, and you can say this is a function. And let's think about it. What means this function, right? What is the meaning of this function? Before we go on, the meaning of this function is you are defining now here in this body of this function how this plus should behave. And what I mean with this, you are defining now how this plus should behave. Let me explain this again in this example here. Here you can see a normal calculation, which is a built-in function in C++, which so let's see what the compiler is doing in this case. So not in detail, but let's assume what the compiler is doing. The compiler goes here and sees, okay, this is a variable. Okay, you want to make an assignment, and to make an assignment, you are using this expression. This expression here has on the left side a 5, which is a literal, and the compiler is converting this to an int type. So when I hover my mouse over it, you can see it is called, okay, not this one. What's going on? I want this one. Why are you not going? Yeah, now it's there. So when I hover my mouse over it, you can see the tooltip says this 5 is converted behind the scene to a int type. Int type is a primitive type, but the left side is the operand of this plus here is a int. and then we have this operand plus, and then we have on the right side this int, this literal 7, which is converted to an int type 7. So important is in C++, this calculation plus here is also defined, let's say it's not really so, but you can think about it, it's similar to this one here. What I mean with that is there is anywhere in C++ a function plus with which the compiler checks then. Well, first of all, the compiler comes here. It reads this plus here because this one is our expression. So the compiler says, okay, this is a plus symbol, but what does this plus mean in this place here? Right? The compiler says how I can check this, what it means in this place here. So the compiler says, okay, I check just what is my left side of this plus. It is an int. Then the compiler says I check my right side. What is on the right side? It is also an int. And then the compiler tries to find a definition in the C++ definition of function if there is something like this one, a function definition, a body, where we have a parameter int. So because this one is an int, so he tries to find an int, and then he tries to find another int here because we need two operands. So these are these two operands, and in combination with this operator plus. So with other words, that what you can see here is already defined in C++ anywhere, and we have here an arrow that is not allowed for us to change. We are not allowed to change primitive operators, primitive types. This is a primitive type, and I don't know exactly the reason, but one of the reasons is because it's already defined in C++. Because when the compiler sees, okay, this is int and this is int, yes, I have already a function defined in C++, and you as a programmer are not allowed to change this because I have this and you should not change this. That's why we have here an error. This one is already a reserved function here because we followed here in this example exactly this syntax here, right? So we created a function here. We changed the function name to one of the special names. Yes, I did. It was this one here. And I used here operands, and that is the thing what I made wrong. Because here on top, at the first sentence, it says here, I'm not allowed to use primitive types, because here it says you have to use a user-defined type when you are doing operator overloading. And in this case here, when you watch this careful, this one is not a user-defined type. This is an int. Int is a primitive type. This is not a user-defined type. This is also a primitive type. So it says here I have to use one user-defined type. And what is again a user-defined type? So when I hover my mouse over it and you read here this tooltip, it says here it is required a class or enum type. So a user-defined type is a class type, which is class. And then you can use this class as a type here. This is a user type, or a enum type, which we have already talked about enums too, is also possible. All right. So with other words, what I have to do as a next step is just change one of this, because this one, like I said, is not allowed. It's probably already defined, and that's why you should not change it. So, but now I give this function a new meaning. I take here, okay, my special add. I add this here, my special add, and you can see this is the type. This is the parameter of this type. And now the error is gone. We are allowed to do this. Nice. Okay, we created a function, at least this function name, and now we have the right parameters. This is allowed. And the next step is now, like I said, you are defining in this function body how this plus here should behave. All right, let's see what this behavior means. All right, so let's think about this one a little bit more. When we read here again this example here, int result 5 plus 7, we know exactly what the compiler is doing, right? The compiler is taking the number 5 plus adding the number 7, and the operator plus behaves like it says, okay, I will add these two numbers for you and write this, assign this result here in your variable. So our result is 12 because the compiler is adding in this case. And like I said before, this adding here is anywhere defined in C++ already. Now, when we are redefining or changing the meaning of plus with a special type, then we can say what should be printed out, for example, or what happened when we are using this plus. And let me make first a demonstration to understand this. At the start, it's hard to understand. So I say, okay, when you are using this plus in combination with a type of my special add and this int, the result is all time. Let's make here a return type perhaps. Let's make here int as a return type. I change just here the return type because I want a return type. You give here parameters and this body is doing something and gives you a return type back. And let's write here return all time. I don't care what you did here, for example. Return all time 100, for example. So that means if you are using a combination of my special add plus int, it will return all times 100. Doesn't matter which arguments you give in. That makes not much sense right now. This is not a real use case. This is just to understand what this body is. Later we make an example which makes more sense. So, but let's see what happens. So now I have defined a full function, operator function, and this operator function, like I said, will be activated when you call it. There are different ways to activate it, but one very easy way is let's get rid of this one right now. So one very easy way is, first of all, you create a variable with this type, then you have a variable with this type, and then you are just adding these two variables with plus, and it will be activated like this result example which I made before. But let's make it. So let's create my class. Here is my class. Okay, let's create my special add, and this is my type. The variable name is my add function, my add class. Let's call it my add class, and I have to provide here argument because here we have to initialize this. Okay, let's provide it. I provided, for example, 10, and then that's it. And now we have this variable. Let's make here, we need also a type of int. Let's make an int type as well. Int, let's say here number, random number. All right, and let's assign this one here, for example, 5. So we have now this type, which means we can call this function here. But here one interesting thing, the interesting part is this function normally we call a function with the function name, and this one works here as well. So we can get it, so call this. So you can use here the function name and then here the parameter list, of course, and now I can use here my class, copy in, paste. And the second argument I need is this random number, just like a normal function, absolute normal. And this one, but we have here a return value, so this one will return something. And let's make here, for example, we can make here one more int result. Let's make this int result by default 0 and use this one here. Result equal this one. And you can see this return value will be saved now in our result, right? So let's test this, but we will see nothing here. So let's put this perhaps out as well. It is see out, and you can let's see and see what happens. So yes, it happens exactly that what we expected. We have here this normal function call, just a different name here, and this name is just indicating we have changed the meaning of plus, which means now we can add us or combine a special type which is called my add class with this type here. And this definition is defined here, and there is not much actually. I just returned 100, and doesn't matter what it is, so it doesn't matter what I provide here, it is all time 100. So it is 100, that's okay. And if I create other my class objects here or other int random numbers, it will be all time 100. And you see this example makes no sense, but it is demonstrating that this one works. But here one more thing, very important. First we saw when we have this result, let's take this result here, oops, result here again. But before I showed you this operator, this one here, this plus operator works without a function call, right? And that's this one here, that was this example, this built-in example, right? And actually this is working with operators as well. So what I mean with that is, this was here int, and now result equal. You can write, instead of calling explicitly this operator with this argument, you can just write my add class, my add class, this one here, plus random number. And now you can see this one is calling this function here as well. And this one will return also 100. So let's see if this is working. Let's go. This one. This one we don't need. And let's see. My class. Why I have not put it out? I don't know. All right. Here's one more SED. See out. Why I have oversold. So, all right. Let's do this one here and see if this is true. Yes, we have again 100, and I have commented out this other one. So the other function call was not activated. It was just this function call was activated. And this is the new thing which we have to learn in operator overloading as well. This one is calling this function here, this little operator. Till now we learned all time we have called this with this function call. This was the normal way. This one works here as well, but we can skip this way now and call it like this. And that's why I explained to you it's very important what the left side is and the right side is, because depends on these positions we are defining this function here. And let me make here a better function definition here, because this function definition here is really bad. And to make it better, let's use these parameters, right? Now you can see this plus here was 100, and I just can redefine this body, and it is doing exactly what I want it should do when I have this type and this type here. So let's say I want first get this num param. That's number param, and this number param is my user defined class here. And because this one is public, I can access this one here, the special number. Let's get the special number here, access special number. And I want that the special number will be added with this argument on the right side. This one will be my right side operand. All right, let's say here number 2 param, this one. And of course, I have to return this because this one is just my return value. This one will be very important. This number special number must be an int. And the reason for that is this operator here, which you see this plus here, it is not overloaded. This is the standard C++ operator. What I mean with that is the standard C++ operator says, oh, I check the left side. This is our integer. You can see it finds this integer type int. Then it checks here the right side. It finds here again this int, and like before, int and int is defined in C++ in combination with plus as an addition, right? And the compiler knows, okay, I know here you want add two numbers, just add two int numbers, which will result in just addition. But here in this place, the compiler goes in and says, this one is a user-defined type. So it is not something what the compiler has in its function, default function library, which means he must check now if he can find some defined function in this case. So we have here this user-defined type, my special add. On the right side, we have an int, and in combination with plus, the compiler tries to find now if you have defined something like this in your code. If not, it will complain. If you defined, it will use it. So for example, I could here comment here fast, and you can see it's complaining now because this operator compiler goes here, and when I hover my mouse over it, the compiler says no operator plus matches this operand. So you can see the compiler checked this side, and he found not a definition for it. It's like this one. Uncomment this one, and now the compiler says, okay, I have found a function for this operand, this left side, right side. I found one, and I will use that. And interesting is here that what you define here, it will use it. So let's go on with our example here fast. So let's return something more specific. You can see now I use these two parameters in a different way, and yeah, let's see what happens here. We create a function. Well, first of all, we provide a variable or argument for the left side. This variable becomes an argument for this operator. And this operator here, this definition is using now here this special number. Of course, when you have here more variables, you can even do other things within. You can make calculations, and yeah, you can do whatever you want. And you see now I just adding this together. Let's start this, and now I have something 15, and the reason for that is that depends all the time how you provided, how you created this object here actually. So if I make another object, let me copy this one. And let's write here my class 2 and provide here, for example, 100. So then of course this will be treated differently. So let me go here, and let's write here, let's copy this one here as well, copy here, and the only thing what we change is make here another copy as well. I make two variables. I could avoid this variable, but that's irritating a lot. It's easier when you follow this one. So this here is the first one is using the first, the second one is using the second. So I have to make here a second too. So, and here in outprint, let's print this one out that we see what happens. This is result 2. And here in result 2, like when I start this one, you can see what happens. We get here the number here 15 and here 105. And actually it's very easy when you follow just here this body. It says, okay, this one here is assigning this 100 in this constructor here, and I'm taking just this number and then I adding 5 to it here at this point. So I hope you understand now what a very basic operator overloading is. We will talk a little bit more in the next video, but before that, let me show you one more example. And you should not irritate it by something like that. So this here, let's say I change the return type here to as the string. And now I return here, hello world. I can even make something crazy like this. This is also possible. So when this operator is used, and you can see I use it here, but it is here already complaining. Let's say what they are complaining. Yes, they are what we have? Yes, they are complaining that we are trying to assign here a string here at this. This is of course not allowed. All right, this is okay. It's not allowed, but what we can do is, instead of using this result here and here, we can just throw in this expression directly in it, because now it's a string expression. The return value is a string, and we know we can use it here. And I can use it this one here as well. Let's do it here. Where's the other place here? And yeah, so, and look what I have now. I have hello world, hello world. So this expression here becomes hello world. It is saying, okay, you are trying to my class, this special class, adding with the plus with a random number, which is an int, and result is all time now defined as hello world. I want to show you the strange example only, because that you understand this operator overloading. The most important part is probably what you are doing in this body with this operator, how you are defining this, right? First, you have just to understand, yes, you have to use this operator keyword, then you find the right operator, then you have get the right class which you want change. You can of course get here another class, and then the most important part is that what you do here, how you define this result, right? So this operator. And with that, I want to stop in this video, but we want to continue in the next video a little bit more, because now I made these examples. I show you here a little bit more in detail what all this kind of stuff is. Not too much. We covered a lot. And if you understand this, it's good. If not, no worry. Like I said, in the next video, we do it one more time. But of course, you should read on good C++ books and good online documentations what this operator overloading is. But careful, they will probably talk a lot of other things as well, like I showed you here in this page. There are many things, but we as a starter, really, the most important part is just the syntax one, that you understand this one. And this 1-2 sentence here and the syntax one. These 3 lines are very important. This, and this. And all the other things here, what we can use. This one, skipping, and then here we watch, I made an example with the second one. And in the next video, I want to show you what it means, this a little bit with the member functions and not member functions. Yeah, there needs a little bit more examples for this kind of stuff, but it's not difficult. It is just how you treat this function. And then we will talk about, again, this restrictions. I think that's it. So I probably will make next time just another example in combination with all the other stuff on this page. With that said, if you have any questions like old time or any suggestions and anything else which you want to ask in the comments. And see you in the next video. And like old time, have fun, good luck, and never give up. Bye.